Now we want to look at a bit of a harder problem, and it's a harder problem because we're going to look at where two regions on the lines intersect, and that's what this little symbol means here. That little upside down semicircle, or N, or whatever you'd like to call it, means the intersection of two regions. So we want to graph both of them up, and then what we'll do is see where the shading overlaps, and that would be the region where they both simultaneously, or points satisfy this one and this one at the same time. Now there's only a certain amount of points that will do that, and that's what we want to find. So the process we need to do is sketch the graph of both of them. So graph, if we do 2x plus y less than 4, so we sketch that graph, so we get our points that we're going to graph up, and then we'll check the region which one is going to be in, and then we do the same for 3x minus y is equal to minus 6. Graph it up, and then we see which side the points are going to be in. So when we look at our graph there, so we get the points here. So the first one, 2x plus y is less than 4. Well, there's that dotted line there, and we check 0, 0 in the working there. So you check 0, 0, and 0, 0 is in that region. So that's why it would have been shaded all the way down here. Okay, if we just had the dotted line there, it would have been shaded there. So we found the equation of the line, and it was dotted, and then we found the shaded part, and we shaded this side because 0, 0 was in there. Now for the other line, which is 3x minus y, when we graphed 3x minus y equal to minus 6, so that's what that line looks like. And again, we tested 0, 0, and so 0, 0 was in the region for that line there. So that's why all this part is shaded as well. Now what we do is we look at where the shading of those two overlap. Where they overlap, well, that's where we want our region to be. So we can rub out all the other part, and we want to see where it holds simultaneously. So that's what the intersection does for us. What are the points that satisfy both? And it's everything inside that area. So that's why that part is shaded, because the region we require is on this side of this line, and it's on this side of this line. So it's where the two hold at the same time. So that's what we call the intersection of the two inequalities, and that's what we're doing here now. So we've got to be interested to see what we do with these ones. Let's have a look at some other problems. So this time 3x plus y is greater than 3. So well, that's that blue line there. So we draw up our intersection. We draw up our line there. It's only greater than, so we put it dotted there. Now we look at what side. With 0, 0 doesn't satisfy. We put 0 and 0 there. It's not greater than 3. So everything on this side of the blue line is what we're going to shade. Then we're going to look at 2y minus 5x, less than or equal to 10. Well, that's where that line comes in. We draw up our line as normal. So we draw up our line, and then we see whether 0, 0 satisfies it. So we put in 0, 0, 0, and 0, less than or equal to 10. It is. So 0, 0 is part of it. So we'd shade all of that side of the line. So everything down here is still part of the second region. Okay, and everything up here is still part of the first region. But when we look at where they overlap, it's this shaded part here. So everything on the side of the line there, everything on the side of the line there overlaps. So that's why that part only remains to be shaded. Again, if you want to stop the video at any time and have a practice of the others and see how you go, then do that. But we'll move ahead. The next one, 2x plus 3y is less than 6. Well, that's our blue line there. And we've got x minus y greater than or equal to 4. That's our red line. So again, we're testing either side of those ones. So 0 and 0, 0 holds for this one. At 0 plus 0 is less than 6. So 0, 0 is in the region below the blue line, which is what we want. And we put 0 and 0 in this one, but it's just not greater than 4. So 0, 0 doesn't hold on the side of the red line. So it's everything on this side of the red line. Where do they overlap? Well, where our blue area is there. So again, we're just doing this, what we've done with the other questions before, but we're just doing two regions at the same time. If your graphs come out where you've shaded all that, and then you can show the overlapping shading, that's not a problem. It's often a good idea to actually do different colors with this one. Shade one side in one color, shade the other side in another color, and where your colors overlap, then you have the required region. It's an easy way to see that. We see the next one, y is greater than x plus 4. So that would have a positive gradient, so that's the blue line there. So it goes through 4, so it goes through minus 4 there, and we get test 0, 0. 0 greater than 0 plus 4, it isn't. So we're shading everything above the blue line. And y less than or equal to 6 minus x, well, that's got a negative gradient, y-intercept of 6, is going through positive 6 there. We test 0, 0, and 0 would be less than or equal to 6 minus 0. So 0, 0 is in the region. So it's everything below the red line. So we want where is it above the blue line and below the red line at the same time, we get that region in there. So that's how we go about graphing these regions, like we did in the first lot of questions, but then combining where they both hold at the same time. So we see this one here, y is less than x minus 1. So x minus 1 be the blue line because it's got a positive gradient, goes through minus 1. We test 0, 0, and 0 is not less than minus 1, so it's not in there. So it's shading everything on the line below the blue line there. Y is equal to minus 2x is the red line. It goes through the origin there, so we test another point. If I test 1, 0, so when x is equal to 1, y is equal to 0, and 0 is not greater than 1. We put 1, 0 in there, and well, sorry, can't do that. I'm sorry, we can do that, and we see that it would be in the range. So we have because 0 would be greater than minus 2, so it does hold when we put it there. So everything on this side of the red line will be shaded. Where's it together? In that part. Now, sometimes it might be a good idea, because they overlap, put an open circle there where those two meet. Basically, what's that saying is that the point where they meet is not part of the region. That line's not part of the region. That line's not part of the region. So where they meet shouldn't be part of the region. Sometimes it looks like it's solid, but if you put an open circle there, that's not a bad idea to say, well, where they intersect is not part of that region, because neither of the lines are equal to. This one here, y is greater than 3. Well, we know that would be above the blue line. X less than 2 is to the left of the red line. So where those two hold together is in that part there, where it's shaded. So it's to the left of the red line, above the blue line. Remember, that's a horizontal line. That would be a vertical line. Remember that, hopefully, from earlier on. And again, a vertical line of x is less than minus 1. So greater than minus 1. So it's to the right of minus 1. And y is less than 4. So we graph 4 and it's below there. Again, we might want to put an open circle where they intersect, so that doesn't look like that is part of the region. So that's how we go about doing the intersections of lines. So we've got a couple more to check. Y is greater than or equal to 3x, so we test our line. We've got our line there. We test a point, put point in, see that it's going to be need to be shaded on the right of the line, and y is greater than 2, so dotted line going through y is equal to 2, and it's above it. So we can see that that part needs to be shaded there. And then h, x is greater than 2, so the vertical line there. Y is equal to minus x is that one. And so again, pick 1, 1. 1 is greater than equal to minus 1, so we shade on the other side, on the top side of the line there. So where do they hold at the same time simultaneously? It would be that region there. So keep looking to do the same process every time. Graph your lines, find the regions where they're going to hold, and then have a look at where they're going to hold at the same time. And if we do that, again, we shouldn't have too many problems. So as long as we don't make simple errors with our lines and our substitution, then we should be right all the time.